So good afternoon, everyone. My name is Stefan Schäfer. I'm from OVHcloud, and I'm hosting this meeting today with you. I have with me Richard Curran from Intel, who is Chief Security Officer in the Data Center Group, and I have with me Professor Dr. Christoph Fetzer, who is a co-founder and COO of SCONTAIN. Today, we want to discuss about transforming business through confidential computing, a data privacy breakthrough. And we do it in the following way. I will give a short intro about OVHcloud and the positioning of confidential computing in OVHcloud, which is based on Intel technology. And then Richard will guide us through the technology a little bit more. And then Christoph will finish with a clear practical introduction, how to use it and what to use it for. We will have a Q&A session at the end, and I will be then back to moderate the Q&A session. But first of all, I will give you a quick overview of what OVHcloud is and why we are here today. So OVHcloud is a French-based cloud provider who has a very deep infrastructure vertically integrated, which basically means that our data centers, which the German one is, for example, located in Limburg. We have a number of data centers in France, overall 32 worldwide. And our data centers are all built in our own architecture. This is based on what you see in the right picture, the water cooling technology, which is patented for OVHcloud. So OVHcloud introduced an own water cooling technology, which creates the need for a special data center architecture, and that then automatically led to a whole data center setup, which is individually created for OVHcloud. So that's why we say we are very vertically integrated, because we build our service ourselves, we own our data centers ourselves, we own the network between our 32 data centers as well, and have then a fully independent infrastructure set up for the customer needs. We offer public cloud, bare metal, and private cloud solutions, and we do this in a logic as a French provider based on this independence that we have through our architectural setup. We are a big supporter of European data sovereignty, which means that we are, due to our setup, ideally prepared to support Gaia X, for example, or GDPR, because we are only a European company, or we are a purely European company, to put it like that. And that means that our customers and our data centers are only relying to under European regulations. So we are free from any involvement or impact from US or Chinese regulations, like the Freedom Act, the Cloud Act, or whatever the regulation is called properly in the Chinese world. That's why we are also a founding member of Gaia X, and we believe in the data sovereignty, in an understanding that we want to have we want to provide our customers the capability to understand at each point in time where the data is, who can access the data, and on which legal basis this is happening. And on top of that, we of course want to fulfill all data security requirements that are coming with GDPR and on top of it. So if we say cloud, we want to have a simple to use cloud, which is multi-local, because we have 32 data centers, and you can interact between the data centers as you want to have it. It's accessible, it is reversible. That means we follow open standards. For example, our public cloud is based on OpenStack, and it should be allow full transparency about responsibilities and access. We also support trusted cloud, and we do this in an open trusted cloud logic or setup, and also in the Gaia X setup, where we say the localization of data, the control over data transfer should be all in the full hand of the customer, and he should be totally capable to understand at each point in time where the data is and which security activities are implemented on his data. That means if we talk about security, that means, of course, data protection in the normal way that we all understand, but it also means handle customers' threat, mitigation of attacks, and operate resilient infrastructure at scale. If we talk about security, it's not, we normally are always talking about security of data in motion or maybe data at rest. So we talk about the security of data transfer between two data centers or two servers, or we talk about the data security for data that is at rest, so it is stored somewhere and we encrypt it. But what about the data that is actually in use? And that is where confidential computing comes into place, because we believe that we need to fulfill the full security requirements. And that means not only to secure the data when it is at rest or in motion, but also when the data is in use. And that means when it is actually worked on in the virtual machine or in the interchip or in the GPU that we provide. So that's why we also, for confidential computing, provide the latest technology and facilitate the usage of this technology in our data centers and in our servers. And we do this in a broad and ecosystem that is supporting us. And part of these ecosystems are today with me in this call because we build on partners who can integrate confidential computing in their solution on the one hand, but on the other hand, we build also on partners who provide the technology and the technological basis for this confidential computing requirements of our customers. And one of the most important providers for confidential computing technology is Intel. And that's why this is the point in time where I hand over to Richard, who will explain to us now how Intel is doing this in the SCG technology and what that actually means technology-wise.
So I'd like to take on what Stefan was talking about from confidential computing. Now, it's a new term in the industry. You probably won't be familiar with the actual term, but I would imagine you're familiar with the problem and also what the opportunity that the technologies that we have, like ourselves and SCONTAIN, built on by OVH, can actually deliver to you as a solution. So first of all, let me just go back to why it came about. The challenges have been growing for a number of years based on the number of connected devices generating significant amounts of data. And as that data grew, what we needed to understand is how do you extrapolate value from that data? And that data can come in many forms. So the data in itself can be part of a particular workload, but associated with that workload could be personal information. You've heard the comments earlier about GDPR and the need to protect personal identifiable information. But equally, there could be health records, financial information. There could be health records that we need to ensure the level of privacy and seniority. There could be government workloads, etc. But the ability to extrapolate information from this data and then secure this information or the data is paramount to the success. Now, you heard from Stefan that at rest and in transit are actually pretty much solved for a particular reason. I think most people would agree that from at rest encryption or in flight, they've been solved. The problem that we have is in use. Systems were always designed to maximize the overall performance by ensuring that CPUs could operate with that level of data in use being in the clear in memory, so you can take full advantage of its compute capabilities. However, that created a fundamental challenge for an awful lot of customers, especially when they wanted to use the cloud, because there was the challenges associated with that data in the clear. If you had any malicious insiders associated with some external entity, then they would have privileged access and could access to that data, and that became an impediment for people putting data and workloads in the cloud. Then, of course, as we know, the types of hacks or malware and intrusions that are out there and are becoming so advanced that a lot of the time they're exposed. And in some respects, one feels that as long as you're in control of it yourself, that you cannot take advantage of the cloud because you're basically handing over the responsibility to your CSP. and thereby not fully understanding the entire topography or architecture of what your partner has. So they could be exploited, and thus you would be held accountable. And then how do you allow third parties access to that, ensuring that you're the only ones as a customer who have consent to allow third parties to be able to get access to that. You also want to make sure that that sometimes there is the risk of operating systems and hypervisor and so on, and firmware becoming compromised. You want to be able to be fully in control of a particular workload. You also need to understand that a lot of people before, up until now, was maximizing workload management through their data centers by basically distributing workloads across their data center to maximize TCO. But of course, for a lot of customers, that was another impediment to actually moving to the cloud, because for sovereignty perspective, or knowing exactly what servers are actually running your particular workload, was absolutely paramount to your business needs and your customers' requirements. So that became a challenge. So what we found is partners in the industry, like OVH, came together and decided that what we needed to do to work with that. A lot of the time, you had also got the big global service providers like Microsoft and Alibaba, IBM Cloud, and Swisscom and others came together. And what they needed to do is, how will they ensure that high-value workloads, and this could be your IP, and it could be PII, it could be government confidential information, it could be high-value assets. How do you keep them secure and make sure that the cloud service providers were an extension of the level of privacy that you needed associated with your own infrastructure? And the cloud providers have many programs convincing their customers why they should be trusted. But of course, as we've seen in the past, some of these revelations that came about tipped the conversation, and why cloud security became a fundamental challenge to address that. Confidential Computing Consortium was founded in August 18, and right now there are up to well over 100 partners in the Confidential Compute Consortium, all looking to ways to which it can evolve from different types of technologies, as we progress within the industry at enhancing and developing new security-based architectures to allow people to have that experience of maximizing the cloud experience. One of those technologies that is prominent today is a trusted execution environment. This is what we have in Intel. Is we've got a product called Intel Software Guard Extensions, Intel SGX, and basically what it does, it allows for the capability for you as a user, as a customer, take full control over where you put your data, what you store in memory, and to ensure a level of trust basis associated with that. Remember, with confidential computing, you're moving from originally what was around a platform level of trust now to incorporate workload and application level of trust. So this is about protecting your applications and protecting your workloads and data within the cloud, within memory. And the beauty about SGX is it has a number of some key really important factors. Number one, it isolates itself from the operating system and VM. So if any of them are compromised, your data is absolutely secure. None of the CSP can access or control of that data. You have full control over the size of the enclave and what you put into that particular enclave. And the other important one is around the attestation associated with that. So you have to ensure that as the application can take, as you incorporate SGX, that the workloads and application won't be attributed to a server unless the server meets a certain requirement around patch levels to actual firmware revision, OS, and say, for instance, a large organization that has got a patch management requirement, or you work with other entities outside your company that you want to share data. If they don't have that level of patch revisions done, or a system a level of attestation, then it won't give you access to the data, or won't give you access to the capabilities around that. So thereby ensuring that there's a level of integrity associated with the platforms before it's allowed to run. And that gives a huge amount of reassurance to what I was talking about, is that no one has access to your data while it's running in memory or in the cloud. There's a level of data sovereignty associated with it, knowing where that data is at all times, that you have full control over who gets access to it, and of course the attestation and integrity of the hardware running in that. Now, we had an amazing launch last week on April the 6th, and we launched our Intel 3rd generation Xeon scalable processor. And this has Intel software guard extensions built in to our 2-socket server space. Now, up until now, we have SGX out in the market, and there are hundreds and hundreds of systems already deployed across various different industries, which I'll talk about in a minute. But clearly, one of the areas that we had is it worked in what we call a single CPU, a single socket server with 8 cores, and the maximum enclave size you could actually generate was 256 megabytes. So that had limitations to the size of the enclave, but it also had limitations to a certain degree on performance. But we were happy to announce on April the 6th with the 3rd generation Xeon Scalable that we've now brought SGX into our mainstream server compute. The size of the potential enclaves can get up to 1 terabyte of a protected enclave for code and data. And also you've got the enhancement in overall performance throughput. So it actually negates or minimizes down to a fraction the overall performance overhead that might be deemed to be associated with additional security features. It also has got crypto acceleration technology built in, but it's binary compatible with what we have today. So the ability to be able to incorporate our 2-socket servers in there is absolutely excellent. So we've got broad market and software support. We've got hundreds of designs in the industry, and we've got brilliant partners like OVH and SCONTAIN, ready to deliver on these types of solutions. I have a short video. It's only a minute long. I'd love to be able to play that video now, if I could, just to give you a sample of what's been announced.
Here are 3 things to know about our 3rd gen Intel Xeon scalable processors, codenamed Ice Lake. First, these chips are powerful and flexible. They include a wide range of frequency, features, and power levels and up to 40 cores. They tackle today's toughest workloads for the cloud, high-performance computing, enterprise network, and the edge, crunching data for financial models, manufacturing, genome research, and more. Second, they're smart and more secure. They're the world's only data center processors with built-in artificial intelligence acceleration for faster analytics. And they include Intel crypto acceleration and Intel software guard extensions to help keep data safe and protected. Third, they're part of an impressive portfolio. Customers can pair them with Intel FPGAs, Optane persistent memory, Optane SSDs, and connectivity products for greater performance. Ice Lake helps customers solve complex challenges across the globe.
So as you can see, that is something that we put on YouTube, and you can, along with other videos. We're terribly excited about the launch. It is the best product that we've ever brought to market, and now we've enhanced it with like crypto accelerators and software guard extensions. So we're really excited about the advancement there as we move through the industry. But really, all those types of technologies that we built in have come about because of you, because of customers demanding a capability that we believe will open up opportunities to provide business transformation. We've been working with the financial and banking sector to look at, we'll say, money laundering protection, asset digitization, to blockchain solutions and cross-border analytics. And equally, we've seen a significant growth on the use of SGX as we start looking at supply chain management and healthcare, or genomics and drug discovery using federated learning and multi-party privacy analytics. The ability where before you weren't able to, because of the association with data privacy, share health records so that you get larger data sets and to be able to use AI to analyze these either health records around to create drug discovery, or looking at genomic analysis using very large data sets. We've been involved in projects around COVID to look at the impact it's had on lungs, and as a result of multiple hospitals being able to share data in a way in which they provide absolute security. that they can allow for much greater analysis, so they could accelerate the overall solutions associated with that. And then we got emerging technologies, such as within retail. We got a very large retail company, Magnet in Russia, with 22,000 stores, who are now looking at consumer analytics and be able to share that with their supply chain, so they can analyze the consumer purchasing behavior without them getting any access to personal information associated with that. So all they're looking is actually the goods, the movement of goods, and the purchasing of goods, and how they can improve supply chain and improve preference to customers. And we're seeing that being borne out with edge around the Internet of Things, and also within the comm space. We're looking at ways in which we can derive solutions to provide much greater security, especially over, we'll say, media and video-based solutions and platforms associated with that, to protect the media, to protect customers, and to protect all the financials associated with that moving forward. So we're seeing it as opening up these opportunities right across the entire spectrum. Breaking it down, it comes into what we call 6 fundamental different types. So ensuring that level of security in the cloud for hybrid or public cloud adoption. We're looking at federated learning and the ability to be able to take multiple different data sets from different institutions and being able to look and keep that data sets confidential, and analyzing the modeling and the behavior of those to provide much greater levels of analytics associated with how multiple parties can work together. Privacy preserving machine learning, allowing collaboration between independent data owners on model training, keeping data and IP confidential. And also with those, we talk about federated learning and privacy preserving. And again, down at the bottom there, trusted multi-party. The one thing around the AI we got to do is, how do you keep the AI model in itself protected? By running the application in a secure enclave. So that also needs to be protected, to ensure that that cannot be compromised, because if that gets compromised, it undermines the entire project. And then we've been involved in blockchain solutions using SGX and secure key management, ensuring that the keys are kept in an enclave and doesn't allow anyone access to those keys, particularly in types of platforms like HSMs. We had an excellent win within your region. That is a public project in looking at the digitization of the German healthcare system. And the authorities then looked at a solution defined by Gematik, and what they were able to look at is decide on SGX as the technology of choice for two reasons. One is the ability to ensure that level of protection of data, especially PII, and number two, to ensure the integrity of the systems moving forward. So customers of insurance companies that have sovereignty over the data will be consolidated into a central data repository and improved in data centers across Germany. And customers will allow to get access to those records at any time through an app developed by these companies. And this level of collaboration has derived significant amount of efficiency associated with the rollout of the system across the multiple insurance companies and other companies moving forward. So we're really excited by this, and we've actually, there's been other projects on the go that have been used by SGX as well that we'll talk about very soon, and we make them public. But we're excited about the adoption and recognition that this has been a highly secure environment, that people feel comfortable with the protection of their data moving forward. So really, it's a whole new approach, going from data silos and looking at the challenges associated with analyzing data from an individual set of requirements, to looking at an incentivized collaboration across multiple entities. You've seen OVH's reach at a global level, and the ability for data centers across Europe or across the globe to analyze data sets that'll be required by you, to do it in a way in which can be held private. So your PII is private, your applications are private, it could be your IP is private, and that no one entity can ever get access to that particular data. Then it actually solves a lot of the challenges around GDPR, around regulation, around compliance. And really the real asset is the ability to accelerate your business through the analysis of larger data sets and being able to make much better business decisions associated with that. I'm sure you'll hear more about this with SCONTAIN in a moment. So really, this is around two things, around looking at confidentiality and how to protect data, and integrity and attestation. They're the two things that are really the breakthrough that are associated that you couldn't do before because of being data that was in the clear in memory. Now you can actually do those, and this opens up these opportunities. And what I'd like you to go away and think about as you go back into your companies is understand the types of projects and what's preventing those projects from happening. And is it through a compliance, a regulatory requirement, or looking about the risk associated with, say, if we wanted to work with a partner like OVH, could they give us that capability to ensure that we get that full confidentiality around that data where you are in control as a customer? And then around the integrity of that and the attestation of that within their data centers to allow and to ensure that you are always running on the latest products and to have these rules enforced so that you can be sure that it'll always run and to minimize the risk associated. And thereby you can enjoy the scalability, the TCO, the capabilities of working with a partner like OVH to take full advantage of the cloud economics platform. So this is just an overview. I'd love to be able to have further conversations with you. Please, come back to me with some questions here on the chat box, but equally we can work with you after the call as well. Thank you very much.
Thank you, Richard. And that's the point in time to move over to Christoph and introduce SCONTAIN's case for confidential computing.
Good afternoon, everybody. Thank you, Stefan. Thank you, Richard, for your talks. And this was a very good introduction to introduce kind of what we at SCONTAIN have been doing with SGX. So we actually started in 2014. So when Intel published the SGX specification, the first version, it was very exciting for us. Since this allowed us to solve a problem that we have been looking for a while. And so our interest was in application security. So how can we protect applications, so the confidentiality and integrity of the data, as well as the code, when this application or the service of an application runs in the context of a cloud. So here's one graphics that we copied from Richard, we admit this. And our focus is on applications. So how can we secure these applications? And we have multiple threats, so adversaries that might attack our application via the hypervisor, virtual machines, the operating system, cloud stacks. There are millions and millions of lines of code. They contain always some vulnerability, and these vulnerabilities could be used to attack us. Or there might be also, we outsource the management of certain services, of the operating systems, of the hardware, and so there might be other possibility to copy our data, modify our data, or code even. So our focus with our Scone platform that we have been developing since 2014 actually is to help to protect applications, make it as simple as possible to protect the application. And so what we do these days is that if you have your application already deployed with containers, you can just take your native container that runs on your Intel CPU right now without SGX. Then you can transform that in one step into a new container image that then in which then this service that you have that ran before natively runs now inside of a trusted execution environment, so within SGX enclave. And we do that to protect the data and code in use, but also in flight. So we make sure that also that in case your application or service doesn't support TLS yet, that we can encrypt all the traffic in flight. And also we make sure that all the data that is stored on disk is encrypted, because if you don't trust the operating system, maybe you want to ensure that your data is encrypted with your own encryption mechanism, with your own encryption keys. So therefore, what our focus is to make sure that everything is always encrypted, data, code, and that you are in control of your service and your application. And Richard already mentioned it, so we have to make sure that our code was not modified, our code is not out of date. So therefore, we transparently attest that we have the up-to-date application code, that our CPU has all the newest microcode, so the firmware is up to date. We actually run our application inside a genuine SGX enclave, so genuine CPU, Intel CPU. There was no modification of that. That's no copycat. There's no simulation. So we can attest remotely that this is a genuine SGX enclave, and we can install our applications and services like a normal application. So to the operating system, the hypervisor, it looks like a normal application or service. So we can deploy it on Kubernetes these days. We can support a Kubernetes package manager, which is Helm, to install that. And to Kubernetes, it just looks like a normal application, but the application or the service runs inside of SGX enclaves. And all the traffic, as I mentioned, is encrypted. All the data that goes to this can be transparently encrypted. And for that, you need, of course, keys. And one of the difficult parts is, how can I provision keys to an application that doesn't know any keys yet? Say, consider MariaDB. So MariaDB actually permits you to encrypt everything on disk, so your database on disk, but it has to have that encryption key somewhere. So the default way is to store it in some configuration file that is protected against other users reading that encryption key that isn't a clear text. But if I'm a root user, I can actually read that configuration file, get the encryption key, and get access to all the data there. So what we do is we attest services, and then we can provide that service with keys in such a way that the keys are always inside of enclaves. They are never visible in plain. So you attest the service transparently, then you, if that attestation says, okay, that is the code, it runs on the genuine SGX CPU, then keys can be transferred. They can be even dynamically generated to, for example, your MariaDB, and to generate one encryption key that is then used by MariaDB to encrypt all the files. So you can establish trust with the help of attestation in your applications, in your services. And what we also provide is a way of transparency. So you might know that certificates these days, they are all logged, that are generated by root CAs, and you can verify who generated that certificate. And we actually can also log all the events, so which service is attested, when is a security policy updated, so that you can have transparency in your confidential computation. And we actually can put that in a ledger. This is not a blockchain. This is just a secure ledger that is created with the help of enclaves, where you can protect yourself against corruption of this ledger. So you, in some of our clients use that to, for example, do billing and make sure that services are only used in the context of how they contractually agreed on being used. Okay, so the last point that I want regarding to this slide I want to make is about performance. So Richard already mentioned, so there were older CPUs that were limited, and there was also more limited performance. But now with Ice Lake, you can actually have performance that is close to native performance. So here we have TensorFlow Lite or classification, and their lower bars are better, and actually the Scone part running inside of SGX enclaves is at least as fast as the native execution using Alpine Linux or Ubuntu Linux. So there we typically see performance close to native performance with Ice Lake CPUs. So this is really great improvement. Also, the enclave sizes can be much larger than they used to be. One point I want to make is about protecting application code. So we definitely want protect the data of the application, but often we have seen in clients that they also want to protect their code. So they have, for example, Python code in the context of AI applications, and they really want to make sure that their Python code is protected, not only the data. And they want to protect their code and data against a large number of people that might see that code. So there might be collaborators that also work together with this, say, AI code provider, and we have to make sure that this code provider can actually protect the Python code. Somebody else might protect the data of the result data of that Python code. So we have typically very complex interaction between multiple parties or multiple stakeholders, we call them. And there I want to zoom into one application where that is very important. So what we have seen with multiple customers is that they have confidential workflows. So we have multiple stakeholders. So here we have an example where we have some stakeholder that provides a service S1. And there's IP of this stakeholder in this service S1. So there might be Python code, there might be some configuration data that this stakeholder put lots of effort in and wants to protect it. There might be also another stakeholder, SH2 here, that has a different service that maybe processes the data that was the output of the first service S1. And there is, in this example, there's a third stakeholder that actually operates this workflow, or in this case, it's a confidential pipeline. And this stakeholder has the rights to the data that is produced, but it doesn't have the rights to look into that computation, so into a service S1 and is not into service S2. So therefore, we have to make sure that all the stakeholders can protect their intellectual property. And we also have to make sure that the cloud provider cannot look into that computation. So therefore, what we can do with the Scone platform is that each stakeholder can protect their service with a policy and run this service inside of the SGX enclave. And we can make sure that none of the stakeholders can actually look into that, not even the stakeholder that created that service, like in this case S1. But we can make sure that, say, stakeholder SH in this case can see all the data that is produced, but none of the other stakeholders can see that. And for that, to express these confidential workflows, you need some policies. So what we provide with the Scone platform is actually that you can convert your container image, as I mentioned before, into a confidential container image such that the services run in this SGX enclaves. And we have policies that describe what kind of data and files need to protect it. There might be some keys or giving keys access via the policies. And in this way, each of the stakeholders, as you see, we have 3 containers in this context, they can all belong to different stakeholders. And then there might be one that operates the whole pipeline that provides some ways of interacting between the confidential containers. In this case, it is some encrypted volumes. So all the files that are written are transparently encrypted. All the files that are read are transparently decrypted if the service that writes it is authorized or if the service that reads it is authorized. This was kind of an abstract view of a real application, or one of the real application contexts that we are building with Scone. They are, of course, more like federated learning that Richard already mentioned. Okay, that was my quick intro.
Thank you, Christoph. That brings me back to this slide. Where are we? That slide. And so we have some minutes left for questions. And so let's see. If you have questions, then you can put them into the chat box and we will try to answer as many as possible. I see there are some questions already. So there is one for Richard, and that is SGX just another security feature, or what makes the difference to all the other security features that we've seen before?
Yeah, I think the industry is obviously, because of the challenges associated with this industry, it's got an abundance of various different solutions and platforms that are out there. I think what we've seen is over the last number of years is the advanced threat vectors that we're seeing are now penetrating or potentially can penetrate the hardware. We're seeing a whole change in philosophy around security, which is predominantly up to a number of years ago being solved by the software industry alone. Now there's a need to ensure that we have a zero trust orientation. So the hardware, like anything else, if we're going to work with the likes of yourselves and OVH and SCONTAIN, we want to make sure that we're working together to develop the best solutions. So from that perspective, SGX is not just another feature and a capability. What it is, it actually solves a capability that was never there before, insofar as in all systems that are out there, not just Intel, but all of them, data is in the clear in memory. And whilst a lot of people recognize with the problem, I don't think they actually identified with the potential fixes associated with it. And as Christoph said, it was an area that needed to be addressed. And when he saw the capabilities about SGX, he immediately identified with the opportunity as a way in which they can solve business problems. So this is about business transformation. It's about ensuring that security can actually enable some business opportunities for yourself to secure the last third element of data protection. We have at rest, we have in flight, and now we can protect it in use. That's why it's different to everything, every other capability.
Yeah. Thank you. I think there is one question also that might fit to that. That is, I just read it. All data needs to be decrypted before it goes to the CPU. How can performance be better than without SGX?
I think there's. Let me try to answer that one in the way I understand the question. So all security has, by and large, got some sort of security overhead. The minute you apply some level of test or analysis and or some level of encryption, thankfully in Intel we put a significant level of importance to crypto accelerators. And anytime we're building a piece of technology, we want to ensure to minimize the overhead. So when we're developing SGX, we want to make sure our engineers would actually do so to incorporate all of the performance capabilities that are built in to the CPU to minimize any overhead. And that's not just on a straight CPU operational. This is sort of workload or application dependent. In other words, we're running things, applications like AI. We want to make sure that the inference or training-based applications, that we minimize the overhead. What we're seeing with Ice Lake is there's minimal, if any, overhead associated with it. So by incorporating SGX, the benefits that you're going to see from far outweigh any overhead. And as Christoph has already said and mentioned from his analysis, the overhead is absolutely marginal.
Yeah. I think there is one question that fits nicely to that is, maybe we ask Christoph to answer it. It's what are the limits of what programs can run inside an SGX then?
So since Ice Lake, there are only a few limits. Before there were size limits, but now you can run almost all software in SGX enclaves. There are some limits regarding special operations that are not permitted, but you can actually transform that transparently such that certain operations that are out of security reasons not permitted inside of SGX that can be then emulated in software. And maybe I can also get back to the last question about the speed. I think that was a reference to my benchmark results that I showed. So if you run in the enclave, sometimes you get better speed because the caching can be different. So you can have a better caching behavior. So there, because the CPU has to encrypt and decrypt, yes, that introduces overhead, but if you have it in the CPU and the CPU's, at least in certain modes, keeps it in the cache. Thank you.
Okay, sorry, I was just disturbed. There is another question also for you, Christoph, which is, will Scone functionality eventually be part of Linux distributions or part of the commodity stack?
So we are not yet sure if we release open source. So definitely we have a community edition so everybody can try it out. We have some open source, but it's not all open source. So we have no venture capital, so we need some money someday.
Actually, we all do somehow.
Yeah, yes.
Okay. Maybe you can also elaborate quickly on which programming languages you support.
So we actually support most of the programming languages. So if the programs are written in Java, Python, or Rust, we all support them. So there is actually no practical limits. So there are some programming language that we prefer because they are more security oriented, like Rust. This is of course one of our favorites, but we support also other programming languages, and we see that many actually using Python because that is very popular in AI context, but also .NET applications. They all run inside of SGX enclaves.
Okay. There's one question to OVH, so to me in the end, and that is the question, in which servers do you actually support SGX? If you look at the OVH portfolio on the OVH webpage, there are some servers which are using these Intel chips that are required here, but so you can find it already today in the portfolio. But we are also working on putting Ice Lake into our portfolio and include it there, and you can probably expect something about summer with an offer on that that is then totally fulfilling the Ice Lake promises with OVH servers as well. Then let's see, I'm just scrolling through the questions. Maybe one for Richard. Is confidential computing a pure cloud play, or do we also look at hybrid scenarios?
Yeah, it's a good question. It's a very good question. Now, it started out by cloud, by a lot of the larger CSPs in the world identifying with the fact as why there was an impediment to putting business critical or privileged data onto their clouds, and why for a good number of years with every survey that a lot of the analysts who do, cloud security was always their number one concern. What is it that prevented companies from moving to the cloud? But as we start engaging with customers, people are looking at, we'll say, certain on-prem. So it could be look at supply chain. So partners across an entire, we'll say, manufacturing organization want to work together to manage the entire supply chain of its company, from base components to the output of the product and the go-to-market. But really, again, as companies embrace cloud, they need a professional cloud service provider to work with them. And that could be in association with companies, either to work on multiple party analytics and to use a CSP to be able to work like OVH, or it could be that it could be a hybrid cloud. So there's parts of the infrastructure and application stack would remain on site, but a lot there'd be a gradual process to the cloud. So as we work with companies, a lot of people want to take advantage of cloud, and companies like OVH, but they want to ensure is how can you provide as good security, if not better security. This is the way forward. And so but before we finish, I would like to thank everybody who came on the call today. Sometimes we find that this may be, the concept of it may be quite easy, but when you get down into the next level, it can be quite complex. So if you're still feeling a bit from today's presentation, which is really a flyby to some respects, just get in touch with myself or with Stefan or Christoph, and we can have a one-to-one meeting, or we can have a group meeting and so on, and we can just work through. If you have an issue with how can my company do X or what we should do, we'd be more than happy to discuss that, because we got lots of examples that are out there up and running today. They've been working for the last couple of years. They're fully functional, and people are enjoying that level of capability that is offered in the marketplace. So we're excited by what we launched, and as a result, we've seen a step change in confidential computing. So the timing of getting your information today is absolutely spot on. Now we got to help you realize the opportunity. You may not have an urgent need today, but suddenly when you think about it and talk to your other colleagues, there may be a way in which, yes, this may be, we need to explore this opportunity because it might solve a lot of problems for us today in our company.
Yeah, absolutely. And you have seen in the chat our LinkedIn profiles. But before we close, I still have some questions here. I have to
fire away.
So there is one already ready-built service with these confidential computing enclave size available in the market.
Yes.
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 Yeah,
so
exactly.
we have.
The answer is
I think
clear.
we have over 200 designs from our OEMs and ODMs have put SGX into their hardware. You pick any OEM out there today, and they will have SGX in Ice Lake. It's in every single Ice Lake product that we're currently shipping, and as our OEMs getting ready to ship in volume, there will be a huge significant supply of these products coming to market. So they'll be on your premise, they'll be with OVH and others, very, very shortly. And if not, if you want to do something, today we can work to get you a product so that you can test. But equally, we've been running with these E3 single socket servers for the last good couple of years.
Yeah. Exactly. There may be a question, one last question to Christoph is, how do you protect yourselves against rogue service application administrators?
Okay, so we actually have these policies to protect the service, and you can, and it could be that the administrator that creates that policy is not trustworthy either. And that is a question that we actually get a lot. So how can we protect ourselves from kind of rogue policies? And there you can actually have but you have also in other systems that you have a multi persons that actually have to agree to change a policy or create a policy. And this way you can make sure that you don't have a single point of failure or administrator that can actually change the policies in a way that you don't want it to have.
Okay. Another one is how bad will be performance if SGX will have OS and the app in the enclave? So if we include the operating system into the enclave, will that impact the performance overall? Maybe that's something for Richard or for Christoph.
So typically you would not put the OS inside of the enclave. So there are some library OS approaches where you put also complete Linux inside of the enclave. That gives you worse performance, and also you have a second OS that you don't want to have, because typically you want to have the OS that is provided by your Kubernetes node. And so what we do is we kind of use the underlying operating system, and we only run the application with kind of some shielding that protects the files that are accessed. So we transparently encrypt and decrypt and transparently encrypt the traffic, not only the files. And so in this way, you don't need a second operating system.
Yeah. And just remember as well as you can put the raw data into the enclave, but also you can put it into a container and put the container into the enclave. So you can have an application in the container, but you generally wouldn't put an OS, into the enclave. And for what Christian pointed out.
Yeah. And I think that's basically all. If I look at all the questions, there are some, but it's a bit repetitive to put it like that. So I think we are finishing the hour anyhow. So might be a good point in time to say the last word of thanks. So thanks to all the people that dialed in. If you dial in, it's not the right wording anymore, isn't it? But okay, that came and joined us in this web session. I hope it was a bit interesting for you. And as I said, you have all the contacts in this list. We are more than happy to be contacted or connected with you, by you, over the different channels. Maybe Christoph and Richard want to say a final word as well.
I've said mine, but
you
thank
said
you.
yours.
Thank you again thank you again for attending.
Thank you from my side too. Thanks for attending.
Lovely. Then I wish you all a lovely afternoon or evening. And yeah, we certainly will stay in contact on this topic because it is very exciting and it's just kicking off. So we certainly will continue the discussion sooner or later. Thanks a lot and have a good day. Bye.
Thank you. Bye-bye.